Hey everybody, I just wanted to jump on real quick to give you a demo of my chat app that I created that has memory. Basically, I've implemented RAG along with chat completions and a little system instruction to save memories about yourself in a Gradio app using Python and OpenAI. Kind of like what OpenAI did in their version with ChatGPT, except for this one you can control and run locally and build yourself. So I'm going to give you a full demo from beginning to end and then show you where you can change this and how you can edit it. So let's start with the GitHub chat RAG memory, and we're going to clone the repo. And a quick way to do this is just to go to the folder where you want to work, hit CMD in the Explorer search bar. That opens up command prompt. And then we're just going to paste in that line. Ensure you have Python and the GitHub CLI, I think it is, to use that command. So here's the code. And the first thing we need to do is set our environment variable. And right now it is set to a sample where you can just put your env key in there. And then delete the dot sample from here. And I'm just going to drop one in real quick. All right, so now you take your env sample file and you would change the dot sample, just delete that part, and you have dot env. For ease, I'm just going to drop mine in. And so now we have the environmental variable, and this is basically, just your key to OpenAI. And we're going to run the app real quick. So before I get into editing the code, we'll just run it. So the first thing is to change directory into chat RAG memory. And also, just for ease, the instructions are in the GitHub. So git clone, change directory, activate, and I'll just walk you through all these steps here, the way I do it on my own setup. So the first thing we're going to do is activate a environment for this. So py -m venv.venv will activate a new virtual environment. And what it'll do is set up this folder for you here. So this will allow you to install all your Python dependencies. And then we're just going to do pip. We're going to activate the virtual environment. So .v, and I hit tab to quickly move to the virtual environment folder, and then we're going to hit scripts and then activate. And I'm just hitting tab and then S tab, A tab, and then enter to do that quickly. Now our environment's activated, and you can tell because it has this .venv to the left of our directory. And now we're going to run our main program. First, we're going to install our dependency. So pip install -r and then requirements. So I'm going to hit just R and tab a couple times to get to requirements and install those. So now this is going to install our requirements, everything we need to run the program, OpenAI, Langchain, Chroma database. And I'll explain a little bit how this works while we're waiting for this. Basically, I'm setting up a database, a local database using Chroma. And then we are using OpenAI's vector embeddings to their embeddings model to create vector embeddings for the things we want ChatGPT or OpenAI to remember. So if I tell it my name, or if I tell it my favorite color, or a book I like, whatever context you want to get into. And I just quickly put this together today as a demo so I could share this and let other people play with it and build on it. And so there's, it's really any possibility here. I load things like documents into RAG as well to retrieve them and provide context. Ultimately, what you're doing is creating a system where you can store details and retrieve them at any time at like a later date. So say you turn off the script and turn it back on, you lose the context from the previous conversation, or if you start a new conversation, you lose the context. But this enables you to store things in memory and retrieve them at will, and then pull those things into context. So if you want to build things, for it to remember you, and it thinks that that would be valuable to the conversation, it can retrieve them. And there's a lot more you can do here. You know, you can, I'll show you just a little bit of the code while we're waiting for that to install. Let me close out these others. Okay, so here's a little bit of the code. And this is the front end. It creates a Gradio application. So we're going to run this in our web browser. It's real fast. Just make sure that's running. And then we will, and then we have a little backend code that will run as well. So in the folder, we're going to go to our modules, and then there's a get OpenAI response. So this kind of does all the heavy lifting for our AI model and creating our memory, deleting our memory, searching memory, creating our vector store using Chroma, all of our tool calls and functions, and I'll explain all that kind of toward the end of the video. But let's run the application now. So py main tab enter. So all we've done is clone the repo, set our environment variable, and install our dependencies, and then run the program. And you'll get to see a couple warnings here. I'm running this on some older code that I kind of ported over. I run a ton of RAG projects. And so I just wanted to, like I said, put something together real fast. It looks like I need to update the way I run Chroma and all that, but this still works fine. And so we'll open a new tab, 786. So the address is localhost /786. It's probably 0 for you. Maybe it's 1. It depends on what you're running. Mine's 3, so this is the third. I have two other Gradio apps running right now. Okay, so we're in LLM with memory demo. Down here you can see there's additional input. So if you wanted to run GPT-4o instead of Mini, you can. If you wanted to change the system instructions, here's where you could do that. So I just exposed those into the UI for ease. But now we can ask it things like, I could say my favorite, remember, it's good if you specifically tell it. It will create memories if you're just telling it things from what I've done in testing, but you could say, remember that my favorite color is blue. And you can hit enter or you can hit send. And let's see what happens in the back end. You can see that I've saved that your favorite color is blue. And here's where you can see where this happens. Creating memory, user's favorite color is blue, memory ID, favorite color blue, memory data. So that's all information about the embedding that just happened in the database. So now, you know, we're in the context of the conversation. So of course, if I asked it, what's my favorite color? It's going to tell me it's blue because I just told it. But let's delete the conversation, which means it deleted all the context from the conversation history. And let's start again. And let's say, what is my, I'm going to say, you know, it's easier if you tie it to a memory, be specific. Can you remember my favorite, if I can spell, color? Now, if it works, then it's going to doesn't have any memory storage. So, and you can actually see it didn't even check for some reason, and I'm still experimenting. And I'm going to say, can you search your memory? I found a memory that your favorite color is blue. If you'd like to update or change it, just let me know. So, you know, it's still in development, but of course you can see now it searched because I basically specifically told it. I'm trying to play with 4o and 4o Mini to kind of see which is better at this. I don't know. 4o Mini seems to kind of take the instructions a little better than 4o in my experience, but 4o is perfectly capable and probably definitely more robust and going to provide additional context and, you know, a better answer, I think. So I'd love to see how other people are using this. If it's 4o's better, if 4o Mini's better. I have a study that I'm working on publishing that compares models like 4o and 4o Mini and the use of RAG. And I definitely see a 10 to 20 point increase in using 4o versus 4o Mini, depending on the task. So the quality of the answer is certainly better. But a real high dependency on this is setting the system instructions and getting the AI model to adhere to the system instructions. So I could say, what is my favorite color? Let's just start over with a new conversation. I'm gonna say, what is my favorite color, and give me the memory ID. Your favorite color is blue, and the memory ID for this information is favorite color blue. So I have found in testing this that if I ask it for the memory ID, it'll pull that into context, and then I can, like, if I wanted to change it, say I didn't want it to be the color blue anymore, and then I could say delete this memory. The memory about your favorite color has been successfully deleted. And we can verify that by looking back at the console, and you can see deleting memory with ID favorite color blue. Also in testing, I found that if I ask it, what is my favorite color? And it says your favorite color is blue, and then I say delete that information, it's like 50% chance. It either remembers the memory ID or not. And I think that's really tied into the system instructions. So, I'm looking to improve this and make it better. So better system instructions, maybe pulling the data into a JSON output instead of a string. And I'll show you where I do that right now. So where I'm pulling in the response right here. So, let's do a code walkthrough real quick, and then we'll talk about steps for improving this. Okay, so we start by building the UI. This is Gradio. We set up, it's using blocks, a soft theme, LLM with memory demo. You can see that's at the top of the screen. There's a little markdown, sets the title. We have the drop down and the system instructions, and we set render to false for both of those, so it doesn't show up here and clutter the UI. Instead, it pops them down into additional inputs right here. All right. And then we run the demo and we launch it. You can also share this in a public space by uncommenting this line and then commenting this line. And that'll set that up. Of course, set up a custom admin and password if you like authentication. Then, and then to execute, when we execute the main function, we do chat response, and we import chat response here from our module. I like to separate out my code just a little bit, and I probably should separate it even further with setting the vector store, but this is pretty convenient to keep it in one helper function like this. So ultimately, we set up all of our inputs, our key, and then our embedding function from OpenAI. You certainly could use other embedding functions, like NVIDIA has a really good embedding model. Langchain, there's some open source embedding models that are also pretty good, but in this case, I'm just using OpenAI for ease. And then we set up our vector store. So I'm using Chroma database. You could also use alternatives to Chroma, but this is what I decided to use. And I set up a persistent directory called DB memories. And then we make that vector store persist. And then I set up some functions for the LLM, the language model, to use in its tool call. So we're going to create the memory here, and we're allowing the LLM to write the memory and the memory ID. So you need to be able to tie it to something if you want to delete it. And this is my approach, was to create a memory ID. And then we create that using a Langchain document, and we set up a little bit of metadata. Right now, the source is user. I might open that up to be either source AI or source user. So say the AI decided to make the memory, but in this case, I told it to make the memory. Again, bare bones, MVP to get out the door, but this could be a variable there as well. Memory ID, that's set by the language model. And then I'm just printing some data here to kind of do debugging and work through. Documents is a list, so you could be a list of memories, and you could loop through and create as many memories as you wanted in one go like this, because you can add more than one document. For ease in the demo, I just kept it to one, but this could certainly be expanded to be a list. I kind of already set this up. This could be like 4 memory in memories, create each memory as a document, and then append that as a list, and then this be a list instead of, it is a list right now. This could be a list of all those memories instead of just specifically setting it to memory 1. So 2 lines of change, and you could make this be a list of memories. And then return if the memory is created. And then this one deletes the memory, and then there's of course an exception. I like to create exceptions in every function just for better debugging. And this one's delete the memory, and I purely rely on the memory ID. And this goes back to if you're in the context of the conversation and the part where you get the conversation might not include the context from the complete response from the vector store. I'll show you what I mean in a second. But ultimately, you need the correct memory ID to delete it. So if you say, what is my favorite color? And it says your color's red, and then you say delete that memory, it likes to make up a memory ID. And I spent probably more time debugging that than I did building the project. And it's still not great. So looking for improvement there. Definitely a place where we can improve this, but it needs a memory ID to delete the memory. Okay, so here's where we search the memory. And the way we do that is a query. We build the query and look for matched documents. Out of the box, it searches for 4. If you only give it a couple of memories, there's not even 4 memories in the thing, but right now that's the way it's built. If there's no matched documents, it's just going to return no matching memories. Otherwise, it's going to build a string of injected docs content. It's going to loop through the match docs. So if there was more than one match, it's going to build this return string, basically. It's going to set the get you the memory ID, the source. So if we wanted, again, I brought the source in here. So if we wanted that source to be the user or the AI or another source, that's fine. And then just debugging statements. And then I build the content string for that specific memory. And then we append it to this injected docs content string. And there's a lot of ways to do this. This was a way that I found good success early on and just ran with it. Otherwise, there's an error. And then this function right here is just a helper function to help you execute the function call. I'll circle back to that in a second. So here's where we build the chat response. This ties back to our main function, the chat response. This is ultimately where we do all the work, okay? So we get the message, we get the history of the context of the conversations. So this history object allows you to continue the conversation and keep the context going. We set the model, and then we give the system instructions. So these are all custom variables for each call, right? And then just a little bit of debugging. Anything where you see print right now is just debugging. I probably would remove that as I move this to more production, but this is just for fun today. So we're going to build our tools here, and each tool has a type, a function, and then within the function, you're going to describe it basically. So what is the name of the function? What's the description of the function? What parameters do you need for that function? And the parameters, what's the type? So this is going to be an object. The properties of that object is it's going to have 2 strings. One is memory, one is memory ID. This is basically what the language model needs to create the memory. If you do not have memory and memory ID, it's not going to execute the function. So that's why it will invent, a memory ID when it's creating the memory. So it's like, hey, my name is this. It's going to be like username with an underscore probably. It's not consistent. Probably some more instructions here could make that more consistent and make that a better system. It's pretty loose right now. Here, delete memory, this is the function, a description, everything the same for deleting memory, and we only need memory ID here. And then this one is searching memory, and again, it is a query string text of the memory you're searching for. All these things could probably be improved with better descriptions, better system instructions, and so forth. And now we're going to build the history response. So first we're going to set that history response back to nothing. And I know there's some improvement from Hugging Face and Gradio and the newest version of Gradio that relies on system messages instead of, user variables instead of tuples. I like the tuples because I like rebuilding the history response each time. They say they're going to deprecate it. I really hope they don't, because I need to play more with the newer version. But in my first playing with it, it just doesn't work the same, and I couldn't get as quality of responses. Anyway, with all that said, I build a list back with the history response, the system content, the user responses, assistant response, basically just rebuild the history of the context of the conversation on every call. So it's very customizable. There's a lot more you can do with this here. And then I build the first completion object, and this lets it build the tool function if it's necessary. If not, this is the conversation, right? That's the end of it. And so if I ask it something that does not require memory or a tool call, it's going to still return the response for me. And so then it's going to go, and if it has a tool call, then it's going to execute that function call with that tool call. So the tool call, it could have more than one tool call in the thing, but this one is one, for example. And then it's going to go back up here to that helper function, find the tool call. So if it's create memory, and then it's going to create that memory. It could do more than one tool call in a single response. And it's going to loop through until it gets through all the tool calls. So maybe it needs to create, it needs to edit or delete. It could do more than one thing on one response. But ultimately, we get to this history response, and then we do a second API call to OpenAI to complete the object, basically. And this one, I stream it. So the first one is not streamed, and the second one is. So then we can have that streaming response back in the UI. And then this is how we parse that streaming response. So that's probably, maybe a lot. I don't know your level of experience with this stuff, but I wanted to give just a quick code walkthrough, a splash demo of how this works. And now you can see, again, we can end the conversation. You can say, what is my, can you remember what my favorite color is? And let's see if it does the tool call. And of course, remember we deleted in the last one, and it tries. It does not have any memories because remember we deleted that memory, so now it's not going to find it. So there you go, creating memories, searching memories, deleting memories. You could make these be, some future improvement could be memories that are a subject matter. So like these are personal memories. These are code-based memories. These, because maybe you wanted to make it remember code snippets. Hey, remember that Python function that I really like. There's really a lot you can do with this. This could be a code base for your customers and to create customer memory about, if you're in the crypto space and creating NFT biographies or something, this could be their memories. There's just a lot you can do with this, but basically anywhere where you want to pull context into the conversation. So thanks for tuning in. There's my demo. I know it's probably went a little longer than I expected, but look forward to any feedback, and happy to create other demos that people request or want or whatever. Have a great day. Thanks for tuning in.